Hi guys, hope everyone is fine. So in this video we are going to see about convolutional neural network. It's not about full convolutional neural network, but we are going to see and visualize a part of convolutional neural network and what it's doing inside it. So here I have a representation of a convolutional neural network. So for a convolution neural network, how it's differentiated from a normal neural network is it have this feature mapping, feature extractions on top of this classification neural network. So this is a common neural network which will have a input flattened layer and a hidden layer and an output layer. So that's a normal neural network. So how it's made a convolutional is it's having a feature extraction process on top of it. So for where this convolutional neural network is used in image classification problem, computer vision, so that are the main parts where being used. So we're not going to cover all this feature extraction part, but we are going to visualize what's a simple module on first convolution. So this first thing is named as convolution. So in this video we are just going to see what this convolution is doing inside the box. So there are another feature extraction which is called pooling, which you are not going to cover in this video. So as a basic walkthrough, if you're someone who don't have any idea about this neural network means, I'll just explain you in steps what is it's doing. Even though if you don't understand fully, it's completely fine. So we are taking an image and trying to classify if it's given image is a we can assume from this image it's looking like a car, but our goal is to find out if a given image is a car or van or truck. So that's what we are predicting at the end. So we are on the input, we can see it's taking as a patch, for this convolution. You can see it's taking as a patch. So what will this convolution plus this ReLU do is it will apply features to the to this image, you know uh, and then it will we can't work with the full sized image. Basically we don't need this because uh, the image's size will be big and we don't need to be computationally that expensive. So we need to reduce, and we just it's enough to have only a limited and require number of features to classify this. So what on the next layer it's doing is it's compressing the image size, and again it's doing a convolution which is applying filters to this, and again it's compressing, and then this comes to the normal neural network where this whole set of three-dimensional array is converted into a single array, where so that's why it's called flattened. So the next layer is hidden layer, which can have any activation function. You can try it on your own. And the final is, so since this is a classification problem, we need to have a softmax as your final activation. So on final you will get a score of the like this is a truck or van or bicycle or what kind of this. So the one with the highest score, for let's say this image we are giving a input as like it seems like a car. So out let's say this has a 10 number of array. So all on the output what we expect is the one is the number array of size 1, position 1 is considered to be a car. So we are just mapping like that. So this first position array is expected to have a higher value when compared to the others. So in that way we can know the given probability of this image is to be a car. So we can just map this one to be a car and this one to be a truck. So that's the whole idea behind this. So what we are going to do in this video is this. This is a picture I downloaded from the online. We are just so as I said here, on the first convolution we are just going to apply a filter to the patch of the images and get some feature extracted. So in this picture you can see there are a lot of other things which are not required to identify this person, or to identify if it's a male or female, or if it's a human or a monkey. So it's there are a lot of other features here like reflection and other colors. So we just need algorithm to just predict, to just get the features like its edge of this image. So that's what we are seeing on the right side, which is the convolutional filter applied. So uh, so that's our whole idea what we are going to do today. So for this video I'm just taking a picture of a car. So we can see clearly we don't need to you as a human, you can say, to visualize this as a car. You don't need to know about the car color, it's not important. First, reflection, this reflection from this glass and lighting from this and all other image definitions are not required just to define if it's a car or not, right? So what we are going to just look out is we need a filter which applies and which take its feature like its edges. We are going to detect its edges. So that's what basically we are going to do in this video. So let's dive into the code. That's what your most people are waiting for. So for this convolution I have just created the algorithm to patch the image and apply. I'll be showing below. For first we need to import the car image, where I have already uploaded this car image to this Google Colab, and just we need to read this image and we are getting this height and width. In this process I will just explain you how this whole edge detection is done. So just hold on to this video and we'll finally get an idea of how this edge detection is done, right? So we are going to just import and just visualize how this image look first. So this is how our image look, this is our input image looks. As you can see there are a lot of other features which we don't need to classify this as a code. So right, we just for a quick look we can just take a look at its shape, like it's 900 pixel height and 1200 pixel wide, and we have three color channel. For this classification we are going to grayscale it, so we don't take three color channels RGB, so we don't take all the red, green and blue. So we are going to just take a single color channel and work it on, and we just initialize some if filters. So if you don't understand this now, there's no need to worry about it. I'll just walk you through uh, at the end. So this is the code I've written for filtering this first image to the final edge detection. So convolutional filter class. uh, okay, so I'll just explain you what we are doing here. So I'm taking a two position values, x and y values. So it's just fairly an easy process. If you're someone who doesn't have coding knowledge, I will just show you how. What we are doing is I'll just show you with the visualizations so that you can know for sure what's going on. Position x and y, what I'm doing right now is we need to have a box like this which scans through the image and finds its features. So that's what our main goal is. So this position is going to say what is the maximum position of this side x and what is the position of y. So initially we are going to set both to 0. So that's what we done here, and the result is going to be the final result. And don't mind this, this is not this is a thing what we are getting on each layer. So let's say if I just scanning through this whole process for the one time, this filter will be having the values of the matrix multiplication what we did for this first set. So every time I need to on initially I'm just setting it to this value, and we are just running a while loop so that what this process should look like, it start from first, and then if it's hitting, if this x position is hitting on the top right side, then we need to just move this set this x position to 0 and set the y position to the height of this patch, right? So that way we end up here, and the same process goes on, and once it completed, it comes to this. So that's how it works. um, all right, so let's see, we are running inside a while loop, and we are taking a range of 3. And why it's a range of 3, it's because this filter is 3 by 3, which means the size of this patch size is 3 by 3. So that's the reason we are ranging through the loop for 4. And what we are doing is you can just basically visualize. So this if condition is basically checking like if this position of x, it's almost it's hitting this right side or not. If it's right side, you need to do as we know, we need to do two things. It need to set this position of x to 0 so that it will take this to the start, and it should if the position of we need to set also the position of y to +3 because the size of the height is 3, so that it moves downwards, right? So that's what we are doing here. We are setting this to 0 and moving the position to 3. And till now we've got some values while just scanning, so we need to append those values into the result, right? So um, I have not explained how the filtering is done, but basically it's a matrix multiplication. Like you take this let's say if you take the patch like this, behind it it will be a color pattern of zeros and ones. Since we are taking it as a grayscale, we are having a 0 or 0 to 255 255 numbers. So on top of it we are multiplication with this filter wicket, this filter matrix we are having, right? We are doing a row by multiplication. So that's what we are doing, and what we are doing is while multiplying, we are also summing up all the values. And let me check if I can show you in depth on neural net. Let me see if I can show it in an image. Yeah, that's what we are doing in a nutshell. We are just multiplying these two numbers, um, yeah, we are just taking the input and just applying a filter. We are doing a row based multiplication, let's say 4 times 1 and 5 times 1 and 2 times 1. We are adding all of this for this bit gets, and 0 into 9 and 0 into 6 and 0 into 4 and minus 1 into 2. And for all this patch we are just adding all this multiplication and assigning it to a single cell. So that's what we are doing for all this layer. I hope you got some idea over it. So let's dive back into the code. So here you can see we are just getting all this values. We are just multiplying to the filter and just adding up to the summation, and for entire row we are appending this summation. No, what it means is we're just scanning through, right? We have got multiple sum numbers, and we are adding it to a array, and that array we are just assigning it to the x filter. That's the array which contain all the summation values for that single row scan, right? So once that done, we are going to just x the position to +3, just in case if this gonna break or not. So this condition is just to check if the height is, so we can't just if I don't apply that condition, I'll tell you what will happen. So this is our maximum image. So this is the last row before it. It will scan through it, and it will, since it have come to the position like it's hitting the right side, we are going to move that down. So if the sorry, let's say this is the last layer. If this is going to hit the right side, we just need to check if the y position is hitting the bottom. If it's hitting the bottom, we need to break the loop. Otherwise, what will it gonna do is it's gonna continue. So probably it won't continue because you know the you get a out of bound exception, since it can't find a higher number, since we are just always pressing up this number. So there won't be a bound number to this array, so you will get a exception. So to avoid that, we are just breaking the loop if the if the position of y is greater than the height. So that's what we have done here. And what we are going to do is, after applying this convolution filter, we are going to take up this as a numpy array and show it in a image show. Sorry, it's okay. Let's see. Okay, it was unable to connect. Let me refresh this one more time. Let's see. I don't know. Sorry, my internet went off, so it's not connecting to the server right now. It's connected, so let's check what we left over. So the final thing which is left is just to apply this filter to the image and show us the result back. So for this we are going to check the horizontal filter, and for the next step we are going to see the vertical filter, since we taken an array of two filters over here. So let's see. First, for horizontal filter, it's returning true since it's completed. And in this color format might not being able to see clearly, but in a bit I will show you more clearly. So for vertical we are going to run. So it's returning true and returning this. Okay, I think we can download these two images right now. So what this I am right is doing is it's just writing all this data into this image. So right now I downloaded this two image. So let's open it up and see what we got. All right, looks good. So I hope this is a vertical filter. You can see the vertical lines are just detected perfectly fine. So where are the tools? Okay, here and here. Let me close this and open it from, for some reason it's not going like that. Horizontal. Okay, fine. So as we said on the starting of the video, this is our end goal. So as that we are just did right, we are just inputting this image, and what we got is, I hope this is a horizontal filter. So I'll show you how the horizontal and vertical are differentiated, uh, how the filter differentiate. So in the horizontal, in the vertical filter, you can see the door lines are just visible fine because these are more verticals. Vertical lines are just deducted normally, like you see the number plates, and all the vertical edges are detected fine on this vertical filter. When I move to the horizontal filter, as you expect, all the horizontal lines are detected. You see this line running across our car, and all the horizontal lines are detected just fine. But you see all the vertical lines are not detected properly, like number plate and door lines, which we saw on the previous images. So you know, that's how this whole system works. So when you apply a convolution filter, uh, it will apply a random of many filters to this image and get the feature extracted. The next layer, as we told, is a for that what this convolution does here. And next layer is pooling. We're not going to the pooling. And first convolution, it's applying, it's not this two filters, it will apply a random filter, like the number you mention, you know, just like you can mention like 63 filters, and it will apply 63 filters to this image and get various features of this car and just learn from this data. From here you can clearly see, anyone can tell this is a car for sure. So we don't need this, you see, this lighting effects, colors, and all those stuffs. We just need the dimensions of it. We just this is perfectly fine to fit a machine learning problem. So that's what we are done to this video. So hope you liked it. So basically why we are doing is, you can just get this whole thing, whole process, let's say, you can this all this convolution part done without writing and knowing about this code, like you just importing the TensorFlow library and just getting con2d method to your code. It will work absolutely just like this. But the part what we will be missing if we just writing this code alone is, we will not able to visualize what the computer sees through it, what process we are doing through this. So that's what this main goal of this video, to show you how the things are done inside. So hope you got some clear idea on what this edge detections and feature extraction in done in convolutional neural network, and got some ideas on convolutional modules. So hope you find this video interesting. So let me know if you need a pooling layer video. Thanks for watching. See you next time.